There is an impossible truth hiding in plain sight, and to really grasp it, I want you to picture this for a second. Right now, out on a remote, wine-battered speck of land in the middle of the Pacific Ocean, there is a 4.35-ton slab of solid basalt. And according to a completely definitive 2025 structural physics study, which actually went as far as building a full-scale replica, this massive stone was never dragged on a wooden sled. It was never rolled over a bed of crushed tree trunks. It walked vertically. Imagine trying to move a massive, overloaded refrigerator across your kitchen floor by rocking it from corner to corner. Now scale that refrigerator up to the weight of two pickup trucks, place it on uneven volcanic dirt, and imagine a highly synchronized team of people pulling ropes, coaxing this colossal, top-heavy pendulum to step side to side without letting it crash to the ground during a miles-long journey. This single image remains one of the most staggeringly profound mechanical truths we have ever uncovered in the archaeological record. But more importantly, it acts as the ultimate gateway into a much bigger, almost unsettling question. Think about the sheer scale of the challenge here. How did our ancient ancestors, people separated by massive, uncrossable oceans, living thousands of years apart, with absolutely zero group chats or cultural contact, managed to engineer the most impossibly heavy architecture on the planet? They did it using nothing but raw timber, ropes woven from plant fibers, stone tools, water, and a frankly terrifying amount of generational human willpower. There were no hydraulic cranes, no internal combustion engines, no load-bearing wheels. They just had flesh, bone, and an intuitive, gut-level mastery of physics that didn't require chalkboards full of mathematical formulas to actually work. These were logistical nightmares so vast and complex that entire civilizations effectively had to turn themselves into massive, biological machines just to survive them. So, let's play forensic detective and dismantle exactly how they pulled this off. Because the actual reality of it doesn't involve aliens or lost magic, it involves the weird physics of damp sand, a rogue French architect who threw his entire career away to solve a geometric puzzle on a laptop, and a multi-ton idol that functionally took a stroll down a highway under its own kinetic momentum. If we are going to unpack this mystery, we have to look at the absolute apex predator of ancient engineering. We have to start with the ultimate benchmark, because it establishes the logistical baseline for everything that comes after. We're talking about the Great Pyramid of Giza. The sheer mathematics of this structure are enough to give you vertigo if you really sit and think about them. The pyramid is an amalgamation of roughly 2.3 million individual limestone and granite blocks. Each one of those blocks weighs anywhere from 3 to 90 tons. And they are fitted together with a microscopic, razor-thin precision that still leaves modern structural engineers scratching their heads. This was all achieved in an era utterly devoid of pulleys, iron masonry tools, or even the basic wheel. Yet here we are, 4,500 years later, and it remains firmly anchored to the bedrock, shrugging off earthquakes, sandstorms, and atmospheric erosion far better than steel and glass skyscrapers built just 10 years ago. The very first critical error we need to wipe from our collective memory is the Hollywood illusion of the workforce. If you grew up picturing endless millions of enslaved people being whipped across the burning dunes to drag stones, you need to let that go. It's a historical fabrication that instantly collapses under modern archaeological scrutiny. When researchers actually excavated the transit lugs and the worker settlements, they found something entirely different: a highly compensated, specialized labor force of about 4,000 primary masons and quarrymen. They were backed by a secondary logistical tail of about 16,000 to 20,000 support personnel. These were the people baking the daily bread, brewing the beer, weaving miles of rope, and maintaining the brutal supply lines. Have you ever tried to organize a neighborhood block party or a local music festival? It's chaos. Now imagine a central government successfully feeding, housing, and deploying tens of thousands of citizens toward a singular, obsessive architectural goal, sustained every single day for decades, using nothing more than papyrus ledgers to track the supply chain. It is a masterclass in administration, but the physics problem remains. How do you elevate stones the weight of commercial trucks hundreds of feet into the sky? For a century, the default answer in textbooks was a colossal, straight external ramp running from the desert floor all the way to the top. Today, serious Egyptologists consider that theory absolute architectural nonsense. To build a solid ramp at a functional, pushable 7-degree incline to reach the pyramid's peak, you would have needed more physical material and man-hours than the pyramid itself required. Plus, there is zero geological footprint of such a massive secondary structure ever existing on the Giza Plateau. Enter Jean-Pierre Houdin. In 1999, this French architect took a wild hypothesis originally formulated by his father, practically torched his own comfortable professional career, and spent years sweating in front of a computer screen. He constructed a hyper-detailed, 3D CAD model of the pyramid's internal anatomy, trying to crack the code from a completely blank slate while absorbing intense, often cruel ridicule from the academic establishment. His resulting thesis, the internal ramp theory, argues that an external ramp was only used for the chunky bottom third of the structure. After that, the Egyptians built a spiraling, ascending corridor inside the outer edges of the pyramid itself. They dragged the blocks through a hollow, corkscrewing tunnel hidden just behind the outer casing. Crucially, this explains exactly why there are no remains of a giant external ramp outside. The stones used to build the lower ramp were simply ripped up, dismantled, and pulled into the internal spiral to finish the top of the pyramid. They quite literally recycled their own scaffolding. Furthermore, a cache of logistical papyri deciphered back in 2012 revealed an environmental cheat code. The Egyptians essentially terraformed their own landscape. They dredged artificial canals from now extinct, ancient branches of the Nile directly to the base of the Giza Plateau. They let the natural buoyancy of the river do the heaviest lifting, casually floating 90-ton granite slabs straight to the construction site before human muscle was ever required to strain. And then there is the microphysics of the desert floor itself. Ancient frescoes clearly show a worker standing at the front of a sledge, pouring liquid onto the sand right in front of the massive wooden runners. For generations, historians brushed this off. They assumed it was just a religious purification ritual blessing the ground before the stone passed. They were dead wrong. It was applied fluid dynamics. Think about walking on a dry, loose beach versus walking on the wet, packed sand right near the waves. Adding exactly the right volume of water to loose sand creates microscopic capillary bridges between the individual grains, binding them into a stiff, slick, rigid surface. This specific application of granular physics slashes the pulling friction by up to 50%. The Egyptians didn't just stumble upon this. They institutionalized an advanced physical principle for 1,000 years before modern scientists would ever get around to codifying it in a peer-reviewed journal. But this wasn't just an Egyptian phenomenon, and to really see that, we have to look at what was basically the ancient commute from hell. If we shift geographies entirely, cross the ocean, and move forward in time to the freezing, rain-soaked plains of southern England, we find that Stonehenge represents a radically different iteration of the exact same engineering dilemma. Constructed around 2500 BCE, it is a perfectly calibrated ring of 30-ton sarsen stones and smaller bluestones, maneuvered into an astronomical lockbox using nothing but timber sleds, raw leverage, and brute biological force. But the true mechanical nightmare of Stonehenge was never actually putting it together, it was the commute. The bluestones that form the inner horseshoe were quarried in the Preseli Hills of Wales. If you pull up a map, that is nearly 200 miles away from the Salisbury Plain, moving multi-ton payloads across prehistoric, jagged, densely forested British topography, without draft animals or carts is a staggering proposition. Think about driving 200 miles on a modern highway. Now imagine doing it on foot while dragging a house. The prevailing archaeological consensus points to an amphibious relay system. Workers dragged the megaliths over land using greased timber tracks for short, brutal bursts, but the vast majority of the transit was done by loading the stones onto wooden pontoon rafts and navigating them down freezing coastal waters and winding river networks. Just like the Egyptians, the Neolithic Britons realized that water is the ultimate friction killer. Let nature carry the weight. Once the stones finally reached the site, hoisting them upright didn't involve grabbing them and lifting the dead weight. That would snap a human spine. Instead, they dug deep, sloping pits. They slid the base of the stone down into the hole, and then used immense frame wooden shear legs and massive counterweights to slowly, agonizingly pivot the stone vertically. They didn't fight gravity, they negotiated a truce with it. They broke one impossible, back-breaking lift into 100 tiny, perfectly manageable micro-adjustments. And water wasn't the only trick early engineers had up their sleeves. Let's divert for a moment to the jagged spine of the Peruvian Andes, specifically the towering fortress of Sacsayhuaman, which is essentially a massive, stone jigsaw puzzle. The Incas introduced an entirely different, terrifying variable to this engineering matrix: seismic resilience and frictionless joinery, done entirely without mortar. We are looking at limestone and andesite boulders, some tipping the scales at 100 tons or more, quarried miles away and dragged up steep, oxygen-deprived Andean inclines. But unlike the perfect, smooth geometric cubes of Giza, these stones are chaotic, multi-angled polygons. Yet they fit together with such microscopic precision that, to this day, you cannot force a single razor blade between their joints. For centuries, bewildered European chroniclers assumed this required either demonic intervention or some lost, mythical acidic plant juice that could melt stone like wax. The reality is far more mechanically ruthless. The Incas actively chose not to use mortar, because mortar is rigid. When an earthquake hits and Peru is a seismically violent zone, rigid mortar shatters, and walls collapse. Instead, they relied purely on gravity, friction, and an exhausting technique called scribe finning. They didn't carve a stone to match a predetermined paper blueprint. They carved it to perfectly, intimately match the uniquely jagged profile of the specific stone sitting beneath it. Using an intuitive grasp of 3D topography, workers would suspend a massive new block just inches above the underlying course using earthen ramps and wooden cribbing. A wooden template, or a scribing tool that mirrored the exact bumps and grooves of the bottom stone, was run along the bottom edge of the suspended block. Then came the agonizing part. Masons would use heavy river cobbles, specifically hard hematite and basalt pounders, to literally pulverize the limestone away. Not with metal chisels, with rocks, inch by painstaking, blister-inducing inch, until the profiles matched perfectly. Then came the drop. By slowly removing the wooden scaffolding, the 100-ton block would settle into place. The interlocking, asymmetrical joints essentially locked the stones into a massive, heavy jigsaw puzzle that could literally dance and settle during a violent earthquake, rather than collapsing into rubble. No metal tools, no wheels navigating the mountain slopes. Just a brutally efficient mastery of kinetic energy, meticulous material abrasion, and a culturally enforced labor tax system called the mita that deployed thousands of citizens in highly synchronized waves. It was an infrastructural ecosystem where the geometry was dictated entirely by nature, and the precision was achieved through sheer, unyielding, bleeding hands iteration. All of this brings us right back to those statues that actually walk. We're back on the volcanic shores of Easter Island, facing the resolution of perhaps the most deeply satisfying architectural mystery on record. It's satisfying primarily because the absolute, empirical truth was being openly stated by the indigenous Rapa Nui people the entire time, while Western academics continually dismissed it as primitive, campfire mythology. For nearly a century, scientists argued bitterly in university halls over how the islanders dragged 80-ton Moai statues from the central volcanic quarry all the way to the coastal perimeters. Every single academic theory relied on horizontal transportation. The assumption was, lay the idols flat on their backs, tie them to sleds, and roll them on logs mirroring the techniques of other ancient empires. But the island's physical topography actively rejected this theory. Extensive ground-penetrating radar and physical surveys of the ancient transport roads revealed absolutely zero evidence of timber trackways. There were no deep ruts from heavy sleds. There were no gouges in the bedrock that would inevitably, unavoidably result from dragging 80 tons of dead stone weight. Meanwhile, if you ask the Rapa Nui oral tradition, they steadfastly maintained a very simple answer: the statues weren't carried. They walked. It took until 2025 for a coalition of anthropologists from Binghamton University and the University of Arizona to finally swallow their pride and treat this indigenous history as a literal, testable physics hypothesis. The resulting data derived from complex photogrammetry, 3D center of mass analysis, and live action, muddy boots-on-the-ground field trials proved the islanders entirely right, and the academics definitively wrong. By analyzing 1,000 Moai across the island, including a highly specific subset of 62 statues found abandoned directly along the road network, the team realized the transit statues featured a highly specific morphology. They possessed a wide, D-shaped base and a severe, deliberate forward pitch of about 5 to 15 degrees. This was not a stylistic choice made by a quirky artist. It was functional, kinetic engineering permanently carved directly into the stone. Here is the operational reality of how it actually looked. By lashing thick ropes to the upper torso of the standing Moai, a relatively small, highly coordinated crew could pull rhythmically from alternating sides. Because of that forward-leaning center of gravity, pulling the ropes caused the rounded D base to act exactly like a fulcrum. As the heavy statue rocked right, the momentum naturally forced it to step forward. Rock left, step forward. The Moai literally marched across the island. To prove this wasn't just a fancy digital computer simulation, the researchers cast a 4.35-ton concrete replica with the exact geometric center of mass. They took it to a field, handed ropes to just 18 regular people, and successfully walked it down the turf. Once the initial, heavy inertia was broken, the pendulum dynamics naturally took over, making each subsequent step physically easier for the humans holding the ropes. They calculated that a competent ancient crew could move a monolithic statue roughly 1,000 feet every single hour. Even the roads themselves were in on the secret. They were carved with a subtle concave, U-shaped dip. If you are dragging a wooden sled, a concave road is an absolute nightmare that will ruin your day. But if you are rocking a top-heavy statue, that subtle curve perfectly catches the edges of the base, physically preventing the idol from snapping laterally and crushing the crew beneath it. And what about those 62 abandoned statues scattered along the paths? Early theorists thought they were religious markers. They weren't. The data showed that the closer a statue was to the original quarry, the higher the abandonment rate. They were simply mechanical failures. A stone would chip, or a crew would lose their rhythm on a steep, slippery incline. The Moai would topple over. And because deadlifting 80 tons from a flat position back to a standing one was mathematically impossible with their tools, they simply left the failure in the dirt, walked back to the quarry, and started carving a new one. When you step back and look at all of this, you realize they were all operating from the same universal playbook. So, what weaves the sun-baked sands of Giza, the damp, freezing plains of Stonehenge, the dizzying, sheer drops of the Andes, and the total isolation of Easter Island into a single, cohesive narrative? Here we have 4 completely isolated civilizations, completely devoid of the wheel, iron tools, or mechanical engines, all hacking the exact same unyielding physical constraints of planet Earth. They manipulated friction with water and mud, turning the Earth itself into a lubricant. They replaced brute force vertical lifts with slow, agonizingly methodical fulcrums, pivots, and internal spirals. They outsourced the heaviest labor to the natural buoyancy of rivers and the kinetic, unstoppable momentum of gravity. But above all else, they orchestrated raw human capital with a chilling, beautiful, synchronized efficiency that our highly fractured modern society chronically fails to comprehend. None of this required alien intervention. None of it required some lost, mythical high technology that we've forgotten. It simply required acute, quiet observation of the natural environment, generational patience that spanned centuries, and a stubborn willingness to iterate on a problem until the laws of physics finally surrendered to human hands. They didn't possess modern machines. They built their own out of nothing more than rope, timber, water, stone, and perfectly synchronized human movement, one relentless, rocking step at a time.